All right, let's get back to pathfinding. So if I remember correctly, we kind of wrote out the algorithm and got it to compile. So I want to now take a look at I don't know. I don't really want to debug this, step through this. I think I'd rather just see it. So maybe, yes, I didn't do the reconstitution. So I need to reconstitute the path based on the result and populate it in here. So, okay. I guess let's do a reconstitute path function where I will pass I guess I can just get the I can just get the result from this. And then what do we need? I guess we kind of need everything. I guess we just need parents and the level. I don't know, I kind of want to stick all this into some kind of singular state. But fuck it, I guess. So we'll get back the result from there. Or what? I guess no, let's just get the result. Let's just do this. Result that path will be just equal to that. So that will return a pointer. I guess we also need count. Count path. And then we want a path, which will be, I guess, just v2i's. Or I don't know if this should even be floats. Well, okay, let's just do i's. That will be a separate question that we have to path to actually float position. So this will be a pointer. We need the path, and we need, I guess, path node count. I guess, okay. I just don't know what's the least ugly way of doing this. I guess like that. Okay, I decided to just do this. I overthink shit way too much. Okay, like let's just do this. It's not, you know, beautiful or whatever, but it'll just work. So we just want the nav path by pointer. Whoa, what the hell did I just do? There we go. Okay, so what we want to do is first of all count how many it's kind of ugly. Yeah, I guess let's just do while, I don't know, parents. So okay. Okay, so first of all, who's parent, right? Well, parent of the from, or to. Parent of to. So I guess I need that to I. So I guess let's do vec to idx level w and 2. Right. Check that here. Okay. So let's just take int 2i, and then let's basically, we're looking to find parents until we find a parent that is from. Okay, maybe let's take v to I from v to I2. Oh man, this is just so hard. Okay, I need a second to think about this. Okay, so yeah, I'm just doing it like this. Basically, here I'm just counting the nodes. Then what I'm gonna do is, we also need arena. Yeah, so what I need to do is make result path equal to memory arena push array onto the arena of the size that is path node count and the type v2i. Yeah, so basically here we're first just gonna loop through that until we reach parent that is, or the current, until current node is the from node. We keep going up and increasing the count. So like that, we basically find how big the result should be. And then I need to, I think, loop through this again. And this time let's reset the current node to I again and go until it's from I. But now every time before we move to the parent, we need to say that result path at path node result I path node count minus 1, and then we need to put this at result I minus minus. And what do we put here? We need to convert our IDX to XY, which is current node I we need level W. Is that right? Yeah. Yep. Okay. Okay. And then will it cover 2i? I mean from I? No, right? No, it won't. So basically, I think let's just assert that result index at this point is 0, meaning, meaning we never actually added because that was post decremented, right? And then let's do result path, result index, which now should be 0, is again equal to this. I'm sure you could actually organize this code maybe a little prettier. Maybe you could even not have to loop through it twice, but honestly, who cares? That's probably not going to be the bottleneck of this algorithm, is it now? So what else do we need in result? We need the count. Path node count equals to path node count. And there's nothing to return. I think that should work. This is not parent, this is parents. Right, so we reconstitute path and we get back the result. I think that should just work. Wow. That's crazy. Okay. So of course I don't have right now, I'm not actually pathfinding properly because I don't consider if the tile on the map is walkable or not, but it's still gonna look like something, I think. So I think let's go into sermon.cpp, or no, entity.cpp, and we're gonna be doing some of this now. Let's open navigation again. So we're calling this function, there's no state now. So we just want the level, which we store inside the entity itself as a pointer. No, we don't store the level, we store the pointer to the level inside the entity. And then from where I'm currently, to where my movement target is. And all that is if movement is ordered. Okay, and then we also need the arena, which will be again a pointer stored for it in the store, entity store. And then I basically need to loop through our items in the result. Okay, so path node count. Is that what I called it? Why did I call it that? Node count found. So that's going to be found. And then that's still path, and that's node count. Yeah, so as long as that's less than node count, we increase I, we get our path, we get our node, I guess, of the path, not path result, path at I, right? And I guess we should only do this if path.found is the case. And then I think I have to start actually from 1 and then go from, well, I guess it doesn't matter, but I'll start from 0, but I still need to not count the last one. So we can do node A, v2i node B, which is going to be the next one, I plus 1. Then I need to do this somehow. So we have node A, node A dot x times this guy to convert to pixels and also to float, node AY times s tile pixel height. Whoa. And then the same for node B. And let's just draw each line between each node. How are we doing? So that's not a pointer. Must return a value. Did I remove something? Hold on, let me do, I'm still learning this. Let me do Control X, V, Shift D. And I'm looking for get least. No, did I just miss it? How did it compile before? Let me double check. I guess I never had it. I didn't return it. Oh, easy enough. Except, oh no, that's already a v2i. Okay, return least node. Don't know how it compiled before. Oh, you know, hold on. Did I actually do this? I did. Okay. Okay, so this is where I draw. And then this is if not, it's not if 0 dot. Yep. Okay, I think let's cross the fingers now and run it. Let's just do it. Just see what happens. Okay. All right, so what are we doing? We are trying to, oh, we're drawing Atlas tile map. Uh-oh, what the hell did I do? How do I debug this? Okay, let me see. So there's a global variable for GL state And then here we have default vertex patch. And oh, I'm pushing on the arena. Oh, okay, hold on. So right. Okay, so I'm pushing on the arena. Oh, okay. Actually, no way. So why are you in hex? Right. Okay, so I think. Okay. That's easy. I just need to freeze it before and after, because I treated it like it's a transient arena that I would clear out at the end of the frame, but it's not. So let's do memory arena freeze, and what that looks like is this, right? So we just like save the previous used, and then we will restore it. And all this is courtesy of Casey Muratori of Handmade Hero, of course. That's where I learned this. Yeah, then we unfreeze it. And yeah, it's like very stupid implementation. I don't even do any like, what's it called? Fuck, what's it called? Alignment. I don't do that. Who cares about that, right? Yeah, let's see. What's the arena? That's for now the only one. Game state world arena. Oh, I'm not in the game state. I am in the entity store. Okay. Okay, let's take a look now. Okay, so we're at least not asserting anything, which may or may not be a good thing. So what do I want to see? I want to hold and B. And then what I'll be able to do is go into here and then go into here. I guess let's just do this. So what does the path look like? Like nothing. Wow, that's amazing. Well, I guess let's. Okay, yeah. Continue. Walk into that. I guess let's take a look at this. On path is 0 here. Okay. Is there any easy way to debug this without actually stepping through everything? I guess let's take a look what this stuff looks like. So all that will be 10,000 because it's 100 by 100. So a bunch of stuff. Does that look remotely right? What do I store in here? That's supposed to be an index. Yeah, no, that's not right. What? Oh, we never go into here, I guess. So we never... Okay, hold on. So let's see our G scores. Okay, that's all int max. So we never get tentative score. That's 14. Oh. Oh. $20.25. So this is the first iteration, right? So let's see, what's my node I? It should be, yep, start. Now by now it would have already been removed from OpenSet. Wait, hold on, why is these scores not? Okay, it is 0. It is 0 and neighbor cost is 14. So tentative should be 14 and G scores of neighbor I is okay. Let's take a look at neighbors. Count 8 nodes. Okay, so it gives the same node as everywhere else. What is, oh. Oh my god, okay. That's not the node, that's supposed to be X and Y. No, 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 no. Node.x plus X and node.y plus Y. Let's just hope it works now. Found path is 1. Okay, great. So let's just further cross our fingers and hope that it works. Let's just see the result here. So we got 37 nodes. We got a path. Looks promising. Looks about right. Yeah. Going up. And then we're moving on Y. And then we got some garbage. Okay. Cool. So let's continue. Oh, look at this beauty. Okay, all right. Look at that. So, I mean, of course, it's not right in accordance to the walls, but it's something. How's our FPS? Yeah, goes down a bit, but you know, what did we expect? This is the most inefficient way. Look at these beautiful lines that I did as triangles because I didn't want to do I didn't want to switch modes. I'm too lazy to like adjust my GL code to do that. Okay, so what's the issue? No issue, right? Now it's just to so there's two ways. Either we set the cost to 0 or we just skip that neighbor altogether. I think let's do like, we could have later actual costs of movement in the level tiles, right? Like it's like swamp or something is slower to walk through. So we could do that, account for that in pathfinding. So let's just adjust the cost to that. All right. So yeah, what I want to do here is actually query my level is style blocked, I believe. Style blocked. We have the pointer to level conveniently right in this function. Beautiful. I guess let's just do this. Neighbor equals to this. So we can do blocked equals to that, and then we can do blocked. If blocked, then 0, otherwise do this, right? And I think it's as easy as that. Of course, let's not spawn inside a wall. Okay, that's not very promising. I mean, it's doing something. It's trying to do something. But is it like off by 1 or something? No, it's way more than that. So yeah, I can just breakpoint, right? Let's take a look. What am I looking for? I'm looking to see the first guy's neighbors. So I think just run to here. Let's see. Costs. So we do have 0 on the second neighbor, and the second neighbor is 2619, so that's to the right and to the top, to the up. Does that make sense? Yes, that is blocked. So 3 of them should be blocked. 2, 4. 4 is to the right. Oh, yeah. Right top, right, right. And 7 is right bottom. Yeah, so that's correct. But it's not. Oh! I just said that walls are the best way to go because they have 0 cost. Okay, I need to do the opposite. Okay, I guess I just need to exclude them. So I can't believe I did it. Okay, so I need to first, oops, determine this, right? Determine this. I guess let's just do, okay, let's do that. I guess I might as well do this. here. Okay. And then say neighbor.x, neighbor.y, neighbor.y, neighbor.x. Does it look right? And then we can also do this check here. I don't know, I guess let's do that. I don't know. Slightly more efficient. Right? Something like that. And then we add only in this case. Or rather, if it's not blocked, I just want to walk through walls, I guess. And then we don't care about that here. Okay, see, now it can't walk out of there. That's good. Come on now. Put me in the right place. Okay, that's not good. So we find no path here. Let's break. Let me do this. Add existing item. All of these. And let's just go here. What? Oh, fuck. What? What do you mean? Really? Okay. Oh my god, I keep misclicking. Or misbuttoning. Okay, so fun path is false here. Okay. Fun path is false. Let's take a look at our parents. Okay, can we get this garbage? What is this garbage? That's garbage, right? Ugh. Well, this won't work, will it? Yeah, fuck you. How do I get to this? Okay, what is 2f? What is 2? 37, 15. So it's basically going to be 37 times, no, 15 times 100 plus 37, right? Right? I think so. So G scores at 1537. Or rather, parents. What is that? First of all, I initialize it to 0, right? Oh, I don't. I don't. But is that a problem? Oh, I see why then. Because the zeros is because those are... Why does 0 have so many parents then? If the rest is garbage. Count as 0. Okay. So it's... Okay, so that's what it is with garbage in there. Is that a problem? That there's garbage? I don't think so. Because we never actually get to our parents. Yeah, no, that's not a problem. The problem is that we empty our open set without reaching the target. Okay, I guess let's just dive into this. Okay, I'm not gonna step through this 10,000 iteration loop. Where'd I go? Alright, let's see our open set. There's 1. Can I do this? No. Okay, so there's 1, 25, 20. That's the starting point. Okay. We get the least f-score node, which is going to be the node itself. We get the I, we remove that from open set. Alright, where am I? Sorry, I was distracted. Yeah, so the first guy, I get my neighbors. I only have 1 neighbor. That's not right. Oh, did I mess up this? This is gonna be something really, really dumb. Oh, yes, it is. Very much so. Okay, so this has to be not that. Let's just do this. Yes, look at that. Look at that. Look at that. Huh? Yeah. Wow. beautiful. What can I say? And the thing is, like, we're not actually sagging the FPS. Like, it actually, it recalculates every frame right now. Even when I don't hold the mouse. So it's not too bad. I kind of would like to profile it, but I don't really have that much. I guess I can just profile in VS. I mean, I would just like to time the function, really. But I think that I can still do that. Let's see, how do I do this again? I haven't done it in a while. What the hell is that? I don't think that's the right tool. How do I profile? Oh my god. Oh, yes. Yes, record CPU profile. Okay. Look at that. You get color before. That's the stupidest thing to spend so much time in. But I mean, it will be probably optimized in optimized build. But still, even for debug, that's so annoying. Okay, anyways. How do I main? Draw entities, navigate, nav path to target. 153 milliseconds of CPU time. And total is 8973. I don't know. I honestly don't know what that means. Yeah, obviously those two are the biggest. I don't really know how to quantify that. Like, I kind of want to know the time, which I guess. So, okay, I ran it for 9 seconds, right? And out of those 9 seconds, it spent 153 milliseconds. So that's like 153 over, well, I guess it says that here. 171%. So if we like try to extrapolate this badly, nah, it's not gonna work. I was gonna take percentage of my frame time, but I don't know my actual, how long it actually took to process my frame, because obviously I frame limit. I don't remember. Because I do have end frame timing, which does a bunch of shit. And I do print this elapsed milliseconds, but I don't think I ever actually record it. Well, I mean, I print it if I have that defined, which I don't. Okay. But yeah, I mean, still, like, we definitely know that it's probably a lot less than 60 milliseconds. one frame, 1% of that. Right? Like, it's not bad. Because I don't know, I watched this video by Sebastian Lake or something. I don't know how to pronounce his last name, or even remember what it's spelled as. And it was so weird. Like, his optimized version took 5 milliseconds, I think. Which is I don't get it. I don't know if I'm missing something, but that sounds like a crazy amount of time to pathfind one target. I think in a smaller grid. So I don't know if I'm missing something, or if that's doing stuff in Unity for you. And like in you know, with garbage collector and all that stuff. But if it is, then that's kind of crazy. Like, I didn't expect that to be so bad. Anyways. Yeah, so the next step, and I think, I don't know if I'll do it now. The next step is to actually do theta star. Or should I actually, since I don't want to do this more difficult thing of theta star, I don't want to like start a whole new thing. Should I actually fix some stuff? Should I actually like get the entity moving to the target? There's actually a couple more things, and that's the fact that I also need to move to the actual float position, I guess from float position to the first target, or to the first node in the path, and then from the last node in the path, which is an integer, to the float position that I requested. And not only that, but when I do any angle, I actually want to do any angle from those points. Which, now that I think about it now, it might be kind of hard. Although I guess I can do like a last step where I check line of sight from the float position of that one to the center of the tile of the first node, and then the same for the last node. Something like that. And then if I can draw a straight line, I guess I would check all the first nodes, right? And then see if I can draw a straight line, or like collapse all the first nodes into one, as long as I can draw a straight line, right? Something like that. But okay, I mean, if I just wanted to get a little bit more done quickly, how easy would this be? I mean, if I wanted to like just say fuck it and literally recalculate the path again every time and not worry about that too much right now, I could just do this here. Right, so if we're ordered movement, let's just navigate to the target. That'll be all the same. And if we found a path, let's not draw it. Let's not draw it. Let's just move the entity to the next node in the path, which actually will be, I guess, the node number 1. Some along those lines. I mean, I don't think that's exactly right, but I just want to see how this works. And this has to be converted to float vector. And I don't know when it's done. So I think Maybe that should be enough. All right, I mean, yeah, that's the problem with ending the movement. Oh, wow, look at that. It's a little bit shaky, but I can pathfind to here for all I want. Wow. Would you look at that? That's actually amazing to see this in real time. I've only done this kind of pathfinding for a turn-based game. That's beautiful. All right, I think on this note, I will end it. So goodbye.